Well, this is interesting. In the functional test menu, we have something called clutch tests. First gear clutch test, second gear clutch test, third and reverse. Let's run through these and make sure the second gear clutch is engaging. Because right now it seems like it might not be. Let's back the car out, and we have to have the engine running to perform these tests. Alright, let's try the first gear clutch test. We know that one works. Continue. Engine must be running, brake pedal must be depressed, and parking brake set during the entire test. Transmission temp is good. Move shift lever to D, then continue. Start. Is that it? Okay. I mean, you're already in first gear. Shift transmission in the park. Continue. Second gear clutch test. Continue. Okay, continue. Shift lever to D. Continue. And start. Ah, I hear a bad sound. See, gear second. We have slip. Input RPM should be 0 right now. Very cool. I mean, not good for the owner, but it's a neat test. Exit. Park. Continue. Let's try the third gear clutch test. Okay. Yep. Put in D. Continue. And start. It wants to go. It says first. Okay. Well, as long as the input and outputs are 0, I guess it works. Shift in the park. Continue. Reverse gear clutch test. Move shifted to reverse. Continue. And start. Well, so second gear. We're missing second gear. That's the problem. And the only code we set is 1790, followed immediately after. And I don't know if A, B, C shift or just after a shift. So all data, we can go through the actual functional tests in the transmission for the second gear. And then maybe call Keith or somebody, see if he's seen this problem before. I'm sure he has. It's Dodge Neon, plenty of them out there. And that's the next step. Alright, doing a little research. Pulled up the transmission wiring diagram. 2 pages here that would interest us. So, this is the transmission solenoid pressure switch assembly. There's a power right here, comes from the transmission control relay. And we have low reverse pressure switch sense, 2-4 pressure switch sense, and overdrive pressure switch sense. And then the sense wires go to the PCM. That's also the TCM. It's all in one. And the way these work, there's power up here. There are resistors. And these switches pull this side of the resistor to ground. So let's say if the switch is open, we will have no voltage drop across the resistor. So the sense wire will show close to battery voltage, or I guess open on the data stream. If this closes, this goes to 0. This guy knows, hey, switch closed. Easy enough. What makes these switches open and close? Well, it's the solenoids. 4 solenoids here. Low reverse solenoid control, 2-4 solenoid, underdrive, and overdrive. So 4 solenoids and 3 pressure switches. Basically, we have to figure out to diagnose this problem, meaning right now we're headed to either bad solenoids, bad pressure switches, or bad transmission internal, like a failed clutch. I think that's what it's going to end up, is a failed second gear clutch. However, we have to do this to be 100%. On all data, I found an interesting tidbit here in the PCM description and operation. Right here, clutch volume index, the CVI. We saw that in the scan data. And these represent the volume of fluid needed to compress a clutch pack. So the PCM monitors gear ratio changes by the input-output speed sensors. Those are very important. So basically it controls those solenoids, and by the input and output speed sensors can see if the correct gear is engaged and how well it's engaged. Because you don't want these clutches to slip. You want them to engage softly, smoothly, and then stay engaged when you're driving. So basically that's what it does. It kind of learns the clutch volume index. And here are the proper clutch volumes that the computer has learned. So we are worried about the 1-2 shift, which is the 2-4 clutch, and that guy should be 20 to 77. Doesn't give you units, but in scan data we can actually see in the CVI display what these are. So the LR clutch 47. Come over here, LR 35 to 83. Seems to be good. That's for the 2-1 downshift or 3-1 coast downshift. So when you're pulling up to a stop sign, it'll go directly from 3 to 1 instead of downshifting through second. Okay. Next one, 2-4 clutch 58, 2-4, 20 to 77. So that value seems good. However, if the clutch is not engaging, maybe the transmission control module doesn't even know to try to ramp it up. It's slipping completely. There's no torque transfer. It's almost like the clutch has failed somehow. OD 2 to 3 shift 48 to 150. It's a 93. That seems to spec. UD is currently at 46, and the spec is 24 to 70. So those numbers check out. If you keep reading here, certain mechanical problems with the clutch assemblies, broken return springs, out of position snap rings, clutch pack clearance, improper assembly, and caused inadequate or out of range clutch volumes. Defective input-output speed sensors can cause these conditions. So that's about it. And then it gives you kind of a shift schedule there depending on the temperature. So I still don't have a good description and operation saying when this clutch engages, this switch should change state. However, I think just by doing the manual clutch engagement checks, if that solenoid opens, the pressure should go wherever it needs to go, and that switch should at least change state. That's as far as I can get with this diagnosis, I think. So we'll do the manual or bidirectional check again on the clutches and monitor specifically the states of these switches. So let's go back to our transmission data. And in here, do custom display, deselect all. Let's just do input output RPM, and then these pressure switches, the OD 2,4, and LR. That's all I'm interested in. So right now they're all open because there's no pressure. We can just put it in gear, so in first or reverse, that should say closed. And when it shifts to second or tries to, that should stay closed. And I assume that one will go open. So let's just do a quick little test drive. Alright, car's off. All the switches are open. Let's start up. LR pressure switch goes to closed instantly, even though we're in park. So, okay, that's good to know. Let's put it in reverse. In reverse, LR pressure switch is open and engaged in reverse. Okay. Neutral. Again, that guy went to closed. We're neutral. Drive. It says first. Same state. Closed. Open, open. Alright, so let's back up. Now we're in drive. First gear. Let's see what happens when it tries to shift to second. I assume that guy should go to closed. There it is, closed. And we have no power in second gear. So I think we're just about done with the diagnosis, short of tearing the transmission apart, which, I mean, if I had infinite time, I'd probably try it, but in this case, I'm not a transmission repair shop, so he's just missing second gear. Internal transmission problem. Guaranteed. No question about it. So the 2,4 pressure switch closed, we got no power. Put it in reverse. Reverse works. Put it back in drive. It's stuck in the limp home mode. And you can hear something rubbing. Like, yeah, the clutch is bad. So maybe a band or something. We could look up how to tear it down, what kind of labor times there are, how easy it is. Maybe it's a simple problem. I don't know. You just pop off the transmission pan and there it is. But in terms of the diagnosis, that's it. Mechanical problem inside a transmission, unfortunately. And we're gonna have to leave it at that for now. Thanks all for watching. See you guys next time. Bye-bye. Now a little bonus footage, just doing a little more research on how this transmission is put together. To take off the 2,4 clutch, there's a lot of disassembly that has to happen. The oil pump, valve body, etc. And then finally, you need special tools to compress there's the oil pump gasket, bypass valve, there's the input shaft, remove input clutch assembly, okay, and finally you get to the, let's see, thrust plate, sun gear, blah 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 blah, needle bearing. So this special tool, compress assembly, remove the snap ring, and finally you can remove the 2,4 clutch and get it out of there. So that's that. That's just to get to it. We can look up labor times, transaxle. Let's see, parts and labor. Diagnosis. 2 hours. New transmission, $2,700. So about the same as the Nissan Rogue. Complete assembly without transfer of parts. 3 hours to swap it out. I guess it's not too bad. With transfer of parts. And then overhaul rebuild. It's like a 10-hour job. And honestly, I don't have the tools or time to dive into this. Wish I could. If it was my own car, nothing to lose, but I'm sure the guy wants it fixed one way or another, or tell him to get another beater. This thing can't be worth that much money. So we're gonna leave it at that. Thanks a lot for watching. Bye-bye.